All right, today we are actually ending this chapter on kinematics and ending it with graphing. I know, very exciting. So a graph, there are lots of graphs that we could do. The one that we're going to focus on is what's called a position time graph. And the value of a position time graph is that it's going to show us where an object is as time advances. So our horizontal axis will be, oh, I didn't want to go ahead. Our horizontal axis will be, of course, time, and our vertical axis will be our distance unit. So on a position time graph, we would generally have something like this. And right here would be our time units, and for us, in seconds. And going up and down will be our position, and that'll be in meters. Now, the thing about a position time graph is at any point, at any of these points, I could calculate a slope. And if you haven't done slope yet in math class, you could do it with this formula, which is basically rise over run. Rise is up and down, and run is left and right. But generally, we want to go always to the right. So I like to think of it as change in y over change in x. But in this case, our position is, you don't want to get too confused, but our position is on the y-axis when we're graphing. But remember, for physics, position are the x values in the formulas. And time is seconds. This is t. So it's actually a t and an x, but from math class, we'll just agree with the math teachers, since I am one. And we'll call this our x-axis and our y-axis like normal, even though y is representing a position and x is representing a time, which is kind of different than what we were doing. So, f meaning final, and I meaning initial. In math class, you might have seen y2 minus y1 and x2 minus x1. That means exactly the same thing. All right, so let's go ahead and take a look at a position time graph. So the question asks us to use the position time graph to find the velocities for each time interval. So over here, this isn't labeled, but this would be our time in seconds. And this isn't labeled, but it should be. This is our position in meters, and this is some motion, some object. Maybe it's a physics cart position. And before we actually do any of the math, let's just kind of analyze the graph a little bit. Right here, what do you think? Discuss with your neighbor. Is the cart going forward, backward, or neither of those things? Pause the video, talk for 30 seconds. Okay. You should have said here, and likewise also right here, notice the position stays 30. Therefore, the cart is not moving. And the same thing's true right here. The cart is not moving. It stopped. It stayed for a length of time of, these are units of 2 seconds, so for 4 seconds right here, the cart is stopped, and for 2 seconds right here, the cart is stopped. It's just not moving. Now, let's think about these. Tell me what the cart is doing for these. Is it backing up, staying still, or going forward? Discuss with the person next to you. And you should have said it is backing up, right? Because we're starting at 30 right here, and then we end up at 20. So obviously it's backing up right here. We're starting at 80, and then we're backing up to 70. All right, I'm going to erase all this ink because it is going to be getting away in our way. And there is some other things that we might want to note about this graph. So I want you to think between what two times, now again, the times are down here at the bottom, between what two times is the cart moving the slowest? Pause the video and talk to your neighbor between what two times? Okay, of course you could say it's slowest when it's stopped, but I'm implying, well, when it's actually moving, when is it the slowest? And I would argue between these two times, it's the slowest because the slope of that line is the least steep. So right here to right here. So that would be between time 20 and 26. The cart is going the slowest besides not being stopped. So now the follow-up question, and that'll be between what two times is the cart moving the fastest? All right, you should have zoned in on this spot right here. It goes from 50 to 80 within 2 seconds. So this is time 20, this is time 18. So between time 18 and time 20 is when the cart is going the absolute fastest. All right, now let's actually go to answer the question. The question asks us to find the velocities for each time interval. When you see brackets like this means an interval. So I want to know what is its velocity from 0 to 4. And on a position time graph, our velocity is going to equal our slope of the line. So from time 0, that would be this point, to this point. So my formula says y final minus y initial over x final minus x initial. And I'll just go ahead, write an equal sign, and figure that out. Well, x final would be the second time. So the second time is time 4. So that's 4. Minus our first time is time 0. So 0 goes right here. And then we have y final and y initial. So it ends up at 30, but it started out at 10. So I have 20 over 4, which is 5. So it went 5 meters per second. Okay, I'm going to do one more, and then I'll let you do the other two. I'm actually going to do the 14 to 18. So I look down here. 14 is right here. Here's 16, and here's 18. Here's 20, and here's 24. Here's 26. So at time 14, we're right here. And at time 18, I'm right here. So here's my formula. Our final y position is 50. Our initial position is 50. Our x final is 18. Our x initial is 14. And I get 0 over 2. Wait, 4. Well, it makes no difference because 0 divided anything is 0. The velocity is 0, which of course makes sense. We talked earlier, this is a flat line and the cart is not moving, so its velocity is 0. I lied. Let's do one more. And then I think you'll do this 6 to 10. Nah, you'll do the 10 to 20. You're going to do this one. I'll do this one. So 6 to 10. 6 is right here. Do you see what I mean? Like here's 6. So we're right here. And then 10 is right here. So again, y final minus y initial, x final minus x initial. And then we ended up at 20. So 20 is the first number. So don't assume the biggest number is always first. We started at 30. So 30 is right here. And then our x final, that would be our 10, minus are 6. So we have negative 10 over 4. So 10 divided by 4 is 2.5, but it is negative because we have negative 10. So negative 2.5. And why is it negative? Well, the car is backing up. So negative. All right. Try this interval. Pause the video. Give it a shot. Then talk to those around you. All right. Let's see what you did. So at 10, so that's this point, to 20, that's this point. I need to calculate my slope. And I do that by doing this. All right. Why final? Well, I ended up at 80. And I started at 20. So 80 minus 20. And I ended up at time 20. But I started at time 10. So 60 over 10, which is 6. So 6 meters per second. So at this time, you should be ready to do your worksheet, which is on position time graphs.